Okay, so we shall start with maxima minima today, and I really recommend that before moving into maxima minima, to please understand increasing and decreasing functions and do sums of increasing functions, because if you are not going to do be good, or if you're not going to understand what how increasing and decreasing functions um, work and what these are, then you're going to move into really uh, difficult place in which is not going to be very comfortable in maximum minima. You do not want yourself to be in there. Okay, so I hope you have gone through increasing and decreasing functions. So let's start. So this is maximum minima. So suppose before suppose we have a function something like this maybe. Okay. Now look at this function. This function is, suppose this is x1, this is x0, this is x1, let this be x2, x3, x4, x5, 6, 7, x8. Okay, so look, from the region x0 to x1 we have an increasing function, right? And from x1 to x2 we have a decreasing function. Again from x2 to x3 we again have an increasing function. From x3 to x4 we have a decreasing function, right? Decreasing function. So let this be um, a, b, c. These points be c, this is d, this is e, f, g, h, I. Okay, so this is x0 to x1, this is part AB, this is part BC, this x2 to x3, this is part CD, and so on. Okay, I hope you understand. This is DE, and x4 to x5, this is again increasing, this is EF, and so on. So look, in the increasing region, what have you understood in increasing functions, increasing and decreasing function? Like what is an increasing function? An increasing function is a function where all the points on the curve will form a tangent which is having an acute angle with the, which is making an acute angle with the horizontal or the x-axis, like theta 1, theta 2, theta 3, theta 4. All these thetas are, see, theta 1, theta 2, theta 3, theta 4. All these angles are basically acute between 90 and 0. So hence this is basically an increasing function. So you see, AB is basically the increasing function, increasing part. Okay, increasing part. AB is an increasing function. Again, BC is behaving like a decreasing function. So between an increasing function and a decreasing function, there is a point at B where the tangent is exactly parallel to the x-axis, right? This point is called a point of inflection. We will go through what is point of inflection, but you can say that B is the point of inflection. It is called inflection. Inflection. Okay. So what is an inflection point? Inflection point is simply a point where the left hand side is some increasing function and the right hand side is a decreasing function, or the left hand side is a decreasing function and the right hand side is an increasing function. So AB is increasing and this is again the decreasing region. Okay, BC. So B point of B is basically an inflection point. Again in C we see we get to see that BC is basically decreasing and CD is again increasing. So point C, at point C we if we draw the tangent is again going to be parallel to the x-axis. So C is also an inflection point. Okay, C is also a point of inflection. Okay, similarly, point D is also a inflection point. E is also an inflection point. F, G, H, these all are inflection points. Okay, I is not an inflection point necessarily. Why? Because in I we do not have a, since HI is decreasing, we require an increasing part here in after I, but we do not have it here. So we are not going to call I as an inflection point of inflection. Okay, neither are we going to call A as the point of inflection. Okay, so but these points B, D, F, H, these are basically maximas. So here, what are the maximas? Maxima is point B, D, F and H. Okay, so this is a very, I'm going to give you first a very top view of what the maximum and minima chapter comprises. Then we will definitely go through rigorous examples and all. Okay, so right now I'm just going to give you a top view model of this entire chapter. So this is maxima, and what are the minimas here? Minima is, look, C is one of the minima. Okay, and E is a minima, G is a minima. Okay. So all these are minima. A can also be a minima, is it? These are the minimas. Okay. Now look at one thing. So these are the maximas and these are the minimas. Suppose we have a curve something like this. Say a curve like this. This curve is basically fx equals to x cube. If you do not know, then it's okay. This is basically x cube curve. Look, in the left hand part, whenever x is negative, in the left hand part, whenever our x is negative, this is an increasing function, behaving like an increasing function. All the tangents that you draw they are making acute angle. All the tangents, they are making what? Acute angle. Again, in this part, this is also increasing function. Look, this is also increasing function. So you can say that point O, this point is increasing, this is also increasing. So this point O, this is called an point of inflection. Point of inflection. This is a different thing. Okay, this is XION, point of inflection. So a point which is where we have one function which is increasing, another followed by another which is also increasing, but the difference is this is a concave up and this is a concave down function. Okay, this is a concave up, whereas this is a concave down function. Okay, so so this is a point of inflection. So what is a point of inflection? A point where we are going to follow the increasing, and again we will get another increasing function. Even a function something like this is also here, also we are this here O is, this O is also point of inflection. Okay, inflection, XION, not CTION, XION. Why? Because this is a decreasing function and this is another decreasing function. Okay, so when decreasing is followed by another decreasing, or an increasing is followed by an increasing, the midpoint, this point where the joining happens, these points are called the point of inflection. And the points where increasing and then we decrease, or decrease then we increase, those points are called inflection. Okay, so let us do a few sums of maximum and minimum. Suppose fx is 3x squared plus 6x plus 8. So we have to find the maximum value, maximum and minimum values, of fx. So look, one thing is, this is a quadratic function. This is already a quadratic function. I hope you know this, that when we have a quadratic function may be like this, or it could be like this, something like this. Okay. Now, this is a smiling curve and this is a sad curve. Okay. This is smiling and this is a sad curve. Whenever we get a sad curve or a is negative, what a means basically a quadratic equation is something like the a square plus bx plus c, right? If the a is negative, then we have something like this, like something like x square plus 2x minus 7, okay, or minus 2x square plus 4x plus 10. Okay, all these curves, a is negative, here a is minus 1, here a is minus 2. So all these curves will be like this. Okay, it can be like this or even this or this. Okay, here all these curves, with all these curves, the a, that is the leading coefficient or the coefficient of x square, is all negative. And with all these smiling curves, the a is always positive. A is always positive. A is always positive. For example, 2x square plus 4x plus 9, or x square plus 2, or x square, simply x square. All these are basically positive curves. It doesn't really need to be like this. It can also be like this or like this, but it will be smiling. Okay. Now, having said this, now look at this example that we have in our hand. Like we have a 3x squared plus 6x plus 8, right? So what is a? A is basically greater than 0 here. A is 3, right? It is greater than 0, so we should have a smiling curve, something like this, or it could be also like this or this. I don't know, but it will be a smiling curve, right? So whenever we have a smiling curve, we will have a point of minima actually. Okay, we will have a point of minima where we will have a decreasing curve and then an increasing curve. A decreasing and then an increasing. So we will have a point of minima. We will not have a point of maxima here. Why? Because there is no maxima. Okay, this will go till infinity. This will go to infinity. There is no point of maxima here. So one thing we can directly notice from such examples that if we know how to understand the curves, then we can definitely understand that these such curves will not have maximas. They will have only minimas. Okay. So let us only found the minimas or the minimum here. Okay. So how can we find the minimum? So let's see. What is 3x square plus 6x plus 8? So we can take 3 in common. So x plus square plus 2. X square plus 2x plus 8. So this is x square plus 2x plus 1. So 8, and we will put minus 3. Why minus 3? Because we have added plus 1. But this is not actually plus 1. We have added actually plus 3. Why? This 3 will be multiplied with this 1 and we have added actually plus 3. So to balance that out, we have to negate 3. So this y is basically this. Y is basically this. Now, we already know that x plus 1 whole square, that is always greater than equal to 0. So 3 times x plus 1 whole square, that should also be greater than equal to 0. If we multiply both the sides with 3, this side remains 0 as well. Now, if we add 5 on both the sides, we get our y on the left hand side, and this becomes 5. So we can say that y is at least 5. So the minimum value of y is 5. So the minimum value of y is basically 5 and the maximum is, we do not know. Okay, so this is the minimum and maximum. So our curve, so this is how our curve will look like, suppose, and this will be 5, and maximum we don't know, but this is the minimum value, and this is the only minima. This is the only minima, so this is the only minimum. So what is the difference between minima and minimum? Okay, minima versus minimum. What is the difference? Look, minima means you have many, suppose you have many kings, right? many kings of various kingdoms. Suppose you have king 1, you have king 2, then you have king 3, and all these kings. You can have many kings, but out of all these kings, the minimum is basically the king which is the least value, which has the least value. Minimum of all these kings. That is basically the minimum. Okay, so for example, you have a curve like this, suppose. Here this point is a minima, this point is a minima, this point is a minima. A, B, C, all are minima. All these 3 points are minima. Okay, but C is the minimum. Here minima is A, B, C. Right? But what is the minimum? Minimum is C. Because minimum is means the least. Again, same about maxima. This is maxima, this is maximum, this is maximum, this is maximum. Out of these 4, suppose this is ABC, this is D, E, F, G. Suppose here E and F are equal. Also G is equal. So basically minimum. So we have 4 maximas here. 4 maximas. So what are the maximas here? D, E, F and G. So suppose E, F, G, all these are equal. E, F and G are equal values actually. E, F and G, these all are equal values on the y-axis. So the maximum will be E or F. Maximum will be E or F or G. Okay? Not D, because D is lying lower. So that's the idea. Okay, so this is one of the sums. Then let's do some more. For example, let's do something like this, modulus of x plus 7 plus 5. Okay. Now what is x plus 7 modulus? X plus 7 modulus, it means that it will be x plus 7. If x plus 7 is greater than or equal to 0, then the answer will be x plus 7. It means x is greater than minus 7. And it will be x minus 7 if x is strictly less than minus 7, right? If x plus 7 is strictly less than 0 or x is strictly less than minus 7. So, and we need to add a plus 5 to get our to make this left hand side into our fx, right? So we'll add plus 5, so this will become x plus 12 and this will be greater than or equal to minus 7, and this will become minus x minus 2, and this is strictly less than minus 7. So this function, this will look something like this, that at minus 7, suppose this is minus 7, this is origin, we'll have no, this will look something like x plus 12 whenever so x plus 7, this will look something like x plus 12. X plus 12 means a curve something like this probably. And suppose here we have minus 7. Another curve is minus x minus 2. This is minus 2. We'll chop off these. So this wing is basically greater than so this is basically y equals to x plus 12, and this is y equals to minus x minus 12, right? And this point will be what? This point will be, you can use this equation, or you can also use this equation. If you use this equation, this point will be minus 7 plus 12, this will be 5. So the minimum value will be 5, okay, and the maximum is, I don't know what maximum is infinite, okay. So the minimum value, so x plus 7 modulus plus 5, it belongs to, the minimum value is 5 and the maximum is infinite. So something like this. Okay. Now I'll tell you, there is a very simple way how you can draw these graphs just by looking at this. Okay. So suppose you have something like this, that x plus 7, well, x plus 7 mod, simply x plus 7 mod. Now first of all, x mod is something like this, like whenever you see something is getting added within the modulus, you will make a left shift of that unit. So by 7 units you will shift left. So we will come to 7 and this. So this new curve is basically modulus of x plus 7. Okay, suppose we shift on the right, like 2, this curve. Now this curve is basically modulus of x plus 2. Sorry, x minus 2. If you move to the right, you will subtract, and if you add, then you will move to the left. Okay, it's as simple as that. This is the very first thing. Or maybe suppose you have something like this. Maybe this is mod x, right? This is module x. If you have to draw a minus mod x, like something like this, a minus mod x will look like something like this. Minus mod x. This part. Okay, it just gets inverted. Suppose you put a mirror on the x-axis, so this becomes minus mod x. Now, if you have to draw something like mod x plus 2, so this is mod x, and here, since the plus 2 is outside the mod, we will make a vertical movement. If it is inside, we make horizontal movement. If it is outside, we make vertical movement. So this is mod x plus 2. This is mod x. Here, suppose this part is 2. Suppose we draw something like this. Okay. So this is minus 4. So this is basically mod x minus 4. Okay. So hence we make if the addition is or the subtraction is outside, we make a vertically up or down movement respectively. And if the addition is inside, then we make a left shift. If the subtraction is inside, we make a right shift. As simple as that. So what is this x plus 5? So since first of all the addition is within, so addition inside we are doing addition, so we will move on the left hand side, minus 7. This is basically modulus of x plus 7. Then we have to add 5. So by 5 we will jump up, and this. So finally this curve is basically modulus of x plus 7 plus 5. Very simple. Okay. Suppose you have to do something like minus modulus x minus 1 plus 3. Something like this. So first of all, draw this x plus 1, x minus 1 mod. Then you draw minus this. Then you simply add 1. Add 3. Okay. So first of all, draw this. This will be on the right hand side by 1. So this curve is basically modulus of x minus 1. Then you draw this. This will be just this will be just the inversion of this. You will just invert it like this. Yeah. So this is basically negative of modulus of this. And then you add 3. So since we are adding, so we will jump up, okay, by 3 units. So 1, 2, 3, suppose this is 3. So this curve finally, this one, this thing is basically negative of this 3. So what will be this point? This point will be 1, 3. Okay, so this is how you can do it very quickly. It has taken some time for me to make you understand, but it is very easy. You can do it in real time very quickly. Okay, let's move on to the 2 more sums, like something like this perhaps. Maybe this sum. Suppose sine of sine x. Okay, sine of sine x. So first of all, what is sine x? Sine x maximum value is 1 and minimum value is 1. Okay. So sine of sine x, this maximum value will be sine 1 and minimum value will be sine minus 1. Okay. Why? Because this sine x, this angle is between minus 1 and 1. So we are just putting these angles here. So this will be minus sine 1 will be the minimum value of sine of sine x, and the maximum value will be sine 1. Okay, simple. What about sine of cos x? Again, if this is our sum, sine of cos x. So what is cos x? Cos x swings between minus 1 and plus 1, right? The minimum value is minus 1, maximum value is plus 1. The sine of cos x will be, minimum value will be sine of minus 1 again, and the maximum value will be sine of plus 1. So this will be minus sine 1 and sine cos x, maximum will be sine 1. So this is the same as well. Okay. So this is how you can do these sums. Uh, more examples, something like this. Uh, Suppose sine 3x plus 4. Sine 3x plus 4. So what is the, first of all, about sine 3x, I don't mind about the 3x, okay. Whatever the angle is, sine will always be between minus 1 and plus 1. Minus 1 and plus 1. Look, basically how a sine works, suppose this is sine x. So this is sine x. Now how will sine 2x work? Let us just understand what 2x is, then we can actually also intuitively understand how 3x and 4x, all these things happen. Sine x is this, it means that in one cycle it completes one revolution. In one cycle it does one revolution. So for sine 2x is double the frequency. It will just double the frequency. The amplitude will remain the same. The frequency will get just the double in sine 2x. So in one cycle, sine x covers one rotation, right? So in that same cycle, sine 2x will do two rotations. So something like this. So this is sine 2x. This is sine 2x. So look, even in sine 2x, the maximum and the minimum values remain the same. Sine 3x will do what? In one completes from 0 to 2 pi. Sine 3x will do three such such movements. Such complete cycles. Three such complete cycles sine 3x will make. But I don't care about how many cycles it makes. I am simply worried about or concerned about what is the amplitude, maximum and the minimum amplitudes. What are they for sine 3x? And interestingly, the amplitudes remain the same for sine 3x as well. So sine ax will be between plus 1 and minus 1 n. Always remember this. Whatever the value of a can be any real value. Whatever the value of a is, sine ax will always remain the same. But however, what about 2 sine x? 2 sine x. 2 sine x will be a little different. Look, sine x is between plus 1 and minus 1. So 2 sine x, we will just multiply 2 on both the sides. So it becomes minus 2 to plus 2. Minimum value is minus 2 and the maximum value is plus 2. So if sine x is something like this, 2 sine x will look something, in 2 sine x the amplitude will change, okay, but the frequency will remain the same. Suppose this is sine x, so this is sine x, suppose, okay, this is 1, this is minus 1, this is plus 1, this is sine x, okay. So how will 2 sine x look? This is 2, this is minus 2. 2 sine x will look something like this. Something like this, okay. This is 2 sine x. Okay. In 2 sine x, the amplitude changes. The amplitude gets doubled. So 2 sine x minimum value is minus 2 and the maximum value is plus 2. So we can say if a sine x, then its maximum value is plus a and the minimum value is minus a. So if this is a sine bx, something like a sine bx, then it will be plus a to minus a. I hope you are understanding this. Look, for this bx, we have no change. Like sine bx is between plus 1 and minus 1, right? Whatever the value of b you put, I don't care, I don't mind. It will remain between minus 1 and plus 1. So sine bx is between plus 1 and minus 1. Now you multiply both all the three sides by a. Then you find a sine bx. A sine bx is between minus a and plus b. Okay. Now b can be any real number, okay, mind you, any real number. It can be a fraction. It can be a fraction which is less than 1 as well. And still it works. But the frequency will change. Obviously, if you put the angle, the frequency will change. Another thing you can also do, that is something like this. That the angle, look, Suppose you have something like this, sine ax plus b, and here is c. This is a bit different again. So let me make it a little easier. So suppose we have something like sine x minus pi by 2. Sine x minus pi by 2. So sine x is something like this. Okay. This is sine x. What will be sine x minus pi by 2? This origin will get shifted in this case to the right by pi by 2. So at pi by 2 this will actually start. Something like this. So this is basically this thing. I know I have messed up the drawing, but I hope you understand. This new thing, this origin will shift on the right hand side. Since you are subtracting something, so the new origin will be this pi by 2. This sine x minus pi by 2 will start from pi by 2. Okay. What about sine x plus pi by 4? X plus pi by 4. So x plus pi by 4 will start from here. Such that this is basically minus pi by 4. So if this is minus pi by 4, so it will look something like this maybe. Okay. Pi by 4 0. This is again pi by 4. Yeah. 2 pi by 2, and this is again pi by 4 added, so 3 pi by 4 and so on. So this is basically sine x plus pi by 4. So anyway, so so sine 3x is between this. So what about sine 3x plus 4? Sine 3x plus 4, we will add 4 on both the sides, on all the three sides. This will become 5 and this will become plus 3. So sine 3x plus 4. Okay, sine 3x plus 4. This is minimum value is my plus 3 and the max value is plus 5. Okay, what about sine 3x plus 4? So sine 3x plus 4. So if the angle is completely this, what about this? For this one, the minimum value is plus 1 and the maximum is minus 1. Okay, but this will make a left shift. Okay, this will make a left shift of unit 4. By 4 units, it will move on the left. Also, the frequency will get 3 times. The frequency of this is 3 times, and also it will make a left shift. Okay. So, yeah. So modulus of sine 4x plus 3. What is the minimum and maximum value of this? So first of all, sine 4x. First of all, just forget about the modulus. Sine 4x will be between minus 1 and plus 1, right? What about sine 4x plus 3? Sine 4x plus 3 will be between 4 and I guess 3, and this will become 2. And if we put the modulus, it will remain the same. Why will it remain the same? Because this is already positive. This thing is already positive. Look, sine 4x plus 3, whatever is within the modulus, that is positive. So if you are putting something positive within the modulus, it will remain the same. So it remains the same. Okay. However, if you have something like this, maybe sine 2x minus 1 and modulus, let's see what is the maximum and the minimum of this. So what is sine 2x? Sine 2x is between plus 1 and minus 1. And sine 2x minus 1, this is between minus 2 and 0. Okay. Now if you put a sine 2x, like look, one thing, now if you put a sine 2x, the maximum value will become 2 and the minimum value will become 0. Okay. So sine 2x minus 1 modulus is between 0 and 2. Okay, now why is this so? Because please understand this thing. If you have a curve something like this, perhaps maybe something like this, this, yeah, this much is fine. Something like this. This is suppose this is y. This is y. Okay. If this is y, so how will mod y look? How will my mod y look? Mod y will look something like this. Something like this. Okay. This is mod y. Okay. So suppose this is 2 and this is minus 10. So this will become 2 and this will become 10. No. So mod y will be between minimum value will be 0 and maximum value will be 10. And look at y. The minimum value is minus 10. Maximum value is 2. Okay. So the moment you put a mod y, the minimum value becomes the maximum actually. Not necessarily. It becomes maximum because minus 10 on modulus, this becomes more than my modulus of 2. And hence this becomes greater, so it becomes like this. Okay. So I guess this part is okay.